Okay, let's try to solve problem number 8. This problem is great because it shows us what forces are at work when something is completely immersed. Okay, let's look at our free body diagram. This is about a block of wood that's tied or tethered down, right, preventing it from floating up. So, as we discussed before, one of the forces is Ft, and that's what we're looking for, right? That is the required. Let's look for that word. What is the tension? And the tension, you should put a box. Tension. So Ft, and that has to be in newtons. Okay? That's the only thing we're looking for. What are the other forces? Well, this has weight. So the weight is going down, and that's the weight of the block, Fg. Aside from that, you can see it's being pulled up. There's a buoyant force, Fb. Okay? So those are the three forces acting on this body which is in equilibrium. Okay? And so let's write down what we're given. Again, circle everything that has a number. So Fg of the wood, right? That's the weight of the wood, is 71.2 newtons. I should be using a pencil. Okay. What else are we given? The specific gravity. Okay, and I'm going to write it here that the specific gravity, which is the density of wood over the density of water, is equal to 0.75. No units on that. Those are the only two things that are given. So what is the basis for our calculations? Well, here we're looking for Ft. So Ft is equal to Fb minus Fg. We are given Fg. It's already there. What we need to know is Fb. And here is the basis. Fb is equal to the density of water, right, times gravity, times the volume of the water. That's displaced. That's Archimedes. He says so, right? And then here we'll write Fg, which is the weight of the wood, is the density of the wood times gravity times the volume of the wood. Okay, another basis that you can say is that here you can write the volume of the wood is equal to the volume of the water. And why? Because it is completely immersed. Look at that. So whatever is in the water was displaces water. So the volumes are equal. Now I'm going to divide these two. Look at what happens. Cancel out G. Cancel out these two because they're equal, right? And so you're left with Fb over Fg is equal to rho of water over rho of wood. Okay? If you're solving for Fb, you just have to multiply both sides by Fg. And that cancels, and you're left with this. So let's write that down. Ft is equal to Fg, and what is this? Look at that and that. They're reciprocals of each other. So Fg is 1 over the specific gravity minus Fg. Isn't that nice? Look at that again. This is water over wood. That's wood over water. Therefore, this is 1 over Sg. And we now have this, we have this, we have that. That's what's given. Look at how elegant the solution is. Okay? 1.2 newtons times 1 over 0.75. Or you can just do this over 0.75. minus 71.2 newtons. And the answer for that will be, okay, again, it's only at this point that I want you to substitute everything, right? So here, 71.2 divided by 0.75 equals minus 71.2. And the answer is 23.7 newtons. Okay? And again, you have to do that twice because you want to verify your answer. Divided by 0.75 equals minus 71.2. Okay, and so that is verified. That is the answer. Okay? Now, what have we learned? It turns out that as a general rule, the buoyant force is equal to weight divided by specific gravity. Always. You can actually memorize this, and that's an easy way to find out what the buoyant force is. Buoyant force is the weight of the object divided by the specific gravity.